Welcome to another episode. Today we're joined by Yoav and Marissa from the account and chain abstraction team at Ethereum Foundation. Guys, welcome and thank you so much for your time today.
Thank you for having us.
Thank you.
Why don't we start with brief introductions and learn a bit more about why you're working at Ethereum Foundation and what are you doing right now?
Yeah, I can kick it off. So my name is Marissa Posner. I work on the account and chain abstraction team doing product.
And I'm Yoav Weiss. I'm a security researcher, and I've been at the Ethereum Foundation for a few years working on security and then account abstraction and chain abstraction.
Awesome. Like out of curiosity, why did you guys decide to work at Ethereum out of all foundations?
Okay, so I started working on Ethereum in 2017. And when I wanted to use it for the first time, just to experiment with the whole idea of smart contracts, and I realized that there is a huge onboarding problem when it took me 2 months to acquire ETH, to pass KYC and acquire some ETH in order to experiment with the contract, even though I didn't even want to do anything financial. I just wanted to try it out. So I realized that if that's the onboarding experience, then we are never going mainstream. So I started looking into how can I improve this UX and the onboarding process, which led me to start working on gas abstraction, on like a way to use the blockchain without having to acquire ETH for gas, and basically enable like collect calls where the contract would be paying the gas on behalf of the user. So I developed a GSN, the gas station network. And from then I started thinking about how else can we keep improving UX. So I started working on account abstraction, and I joined the Ethereum Foundation. I was doing security research at the time, but also started working with Vitalik on how can we do account abstraction and improve UX without sacrificing some principles such as self-custody and not adding intermediaries. And that's what I've been doing at the Ethereum Foundation since.
Yeah, and from my side, so I kind of started investing in crypto back in 2018 or so, and I wanted to understand more about like what I was investing in. And so my background, I was a machine learning engineer before crypto, so I kind of came from the data angle, and I was like, wow, it's so cool, everything's transparent, on chain, and traceable. And so I started building a like natural language processing tool for blockchain data. Because I was using Dune and I thought this is great, but I have a data background, and so it's really easy for me to use this tool. But for someone that doesn't have a data background or is technical, it's hard. So I built that, and I started kind of diving more into crypto. I had a couple other startups after that, and then one of my goals is to really, I would say one of my goals is to positively impact 1 billion people's lives, and I thought, what better place to do that than at the Ethereum Foundation, which has such a wide-ranging impact because everything that's like built on top of it extends from there. So yeah, I thought it was a great place to do that.
Nice. I think like every user in crypto at some point has interacted with Ethereum, right? So like from
Exactly.
the perspective of working at a place that has a high impact in crypto, like I can't think of many better places.
Yeah,
Uh,
exactly.
so what do you guys think is like a misconception that people have about ecosystem foundations? Because like it's a very tricky uh, place to work at because people have so many opinions, right? Like Solana's approach is better or Ethereum's approach is better. You can just never get it right. But as somebody who's working for a foundation, what do you guys think?
Yeah, that's a great point. I think that a lot of times people think that, I don't know, the foundation can, I don't know, help with anything or should always be doing more. I think like I don't know that anyone would ever be like, okay, what the foundation is doing is enough. Um, so I think it's really the role of the foundation to move forward the technological development of the protocol towards ossification, and then also help the ecosystem grow at the same time. I don't think, we're not going to do everything perfectly, but I think a lot of what Tomash has been doing with connecting with the ecosystem side of things and bringing or increasing the dialogue between the foundation and the ecosystem is a great step in that direction.
Add that the role of the foundation is also is also to make sure that Ethereum or whatever product or whatever project the foundation represents stays aligned with its original goals or explicitly changes them if needed. So, for example, if if there's a push to make Ethereum more like Solana, I would say, then the foundation's role is actually to push against it if it goes against certain values such as censorship resistance. So, part of the role of the Ethereum Foundation, the way I see it, is to also make sure that Ethereum stays true to its values.
Mhm. And so how do you guys think about like today's crypto ecosystem, right? Like when Ethereum launched obviously in 2017, the crypto world was a very different ecosystem, right? And like Ethereum was the dominant layer, but today there are so many other ecosystems, right? So how do you think Ethereum Foundation should approach it from like a protecting crypto's core ethos perspective?
Well, so Yoav Vitalik and I wrote the Trustless Manifesto back in November, which came out and outlined a lot of those vision and values for what Ethereum should be, how Ethereum should pass the walkaway test, et cetera. And it got a lot of buzz within the community. People were talking about it for good, for bad. There was talk a lot about a specific line about like financial applications, but I think like overall the main like purpose of that document was to outline the values for Ethereum and kind of what compromises or trade-offs or thoughts that we as builders should be having or thinking about as we're building Ethereum and applications on top of Ethereum. How you should think about designing a protocol, because I think it is the role of the foundation and those that work within it. Again, this document wasn't the Trust Manifesto wasn't an Ethereum Foundation document. It was written by Yoav Vitalik and I. But the whole point of this document was to outline for builders, for the ecosystem, how they can align with those values and what that concretely means for their applications.
On a personal level, like how is it working with Vitalik? Because like I can only look at it as a fanboy, right? Like because we've all heard of Vitalik's tales. Like even when Vitalik makes any transactions on chain, there are tweets about like what he's buying or selling, right? So everybody in crypto is a fanboy. So what is it like writing something like a Trustless Manifesto with somebody like Vitalik?
Yeah, it's it's great to work with someone as visionary as Vitalik, and to see how he thinks about things. And I think one of his unique skills is that he is an incredible writer and an incredible communicator of his thoughts, ideas. And I think that is what has gotten, Ethereum this far is a lot of Vitalik's writing. And so to work with him on a piece of writing, I definitely learned a lot. And excited to do more in the future.
Working with Vitalik has always been great. It's he's a very smart guy, and it's always super interesting to think about ideas together and to collaborate.
Awesome. So why don't we get into the meat of the discussion and talk about the EIL, the Ethereum Interop Layer, which was announced at DevConnect Connect in Argentina. So it's been a few months. Why don't we start at a high level for anybody who doesn't know about the EIL? What is it?
Yeah. So EIL, or Ethereum Interop Layer, basically extends account abstraction to multi-chain execution. So basically, I, as a user, can in one signature authorize and execute a cross-chain transaction while preserving Ethereum's security and trust model. And I don't need to rely on intermediaries. And so multi-chain execution is really an extension or like completion of the same account abstraction roadmap that we've been working on for years. So in that way, we really think that EIL is multi-chain account abstraction. And so it's also important, I think, to be clear about what EIL doesn't do. So EIL doesn't do price discovery or optimization. So for example, like it wouldn't solve problems like a cross-chain token swap, where like I need to get the price of this asset and the execution is dependent on this information that I, as the user, do not have. So for that use case, intents are the best for like quoting, swaps, example. So EIL doesn't try to replace things like LI.FI that optimize like swapping, for example. So EIL is explicitly designed for execution that the account already knows about, and like the calls that it can explicitly perform. So in that way, I would say like EIL extends the account abstraction guarantees, which account abstraction, you can do single chain execution, to multi-chain.
EIL extends the same transaction model that Ethereum is using for everything. So it's just, it doesn't try to add a new capability like intents do. It's just the same old transactions that we all know and use regularly, except that these transactions are now multi-chain in a way that the user doesn't even have to think about. So
Okay. I mean, can you break that down a little bit? Like, what does that mean? Like, that the same transaction on Ethereum is now multi-chain, right? Like, what does that mean? Is it multi-chain from an EVM perspective, or like, is it any chain? Like, what does that mean? Multi-chain execution.
okay, so multi-chain execution. I mean, in a single chain setup, you send a transaction is a transaction is a call to a contract. You basically send call data to a target contract, and optionally you also include value in the call, and then the contract gets executed. So and this so in that sense, it's prescriptive. It's you tell the blockchain, here's what I want to be. I want to execute this call data on this contract, and you don't specify what results you expect out of it, which is the opposite of what you do with intents. You say what to do, not what to achieve. And with multi-chain, we do exactly the same thing with EIL. It's like it's call data to contracts, except that you specify the contracts and the call data for multiple chains, and you also specify the assets you need for each of them, and the gas is also paid. The gas is paid implicitly at the source chain. So it's a transaction in the sense that it pays for gas and it makes calls to contracts, except that it's now happening on multiple chains.
Got it. And from that perspective, like, where does the EIL live? Like, which layer? Is it at the protocol layer? Is it at the app layer? Like, how do you imagine it fitting into the existing ecosystem?
So it lives in the wallet and on chain. Like everything, I mean, since there are no trusted components, so there are no trusted components in the system. There are no intermediaries. There are no solvers. So it has to live either on chain, where there are contracts that enforce everything, and your funds are always on chain and always belong to you, always under your full control, or anything else that happens needs to happen in the user's wallet. And the idea behind it is that the wallet is already the user agent. The wallet is 100% trusted by the user because your wallet has your private key. So it could just steal your funds, it could leak the private key, it could execute calls on your behalf. So if you already trust your wallet, say let's put all the logic in the wallet and not have to trust another party. So that's where EIL lives.
Got it. And because the wallets are playing such an important role, like, do the existing wallets need to change anything on their end, or like implement new logic for this EIL layer to work?
Yeah, they need to. So they need to implement. They need to implement the logic for the EIL logic for performing such transactions. And we are building an SDK to help them. So they could either use this SDK, which makes it simple for them, or they could implement it in a different way. And the wallet just needs to use. So when a dApp wants to do something, the dApp needs to give the user a batch for executing on multiple chains, and we already have an ERC for sending batches. There's the wallet send calls. So we're going to extend wallet send calls to also specify chains. So actually it becomes a batch of batches instead of just a batch. You have multiple batches running on different chains. And when the dApp specifies such batches, it doesn't need to know EIL. It doesn't need to know anything about how the wallet is going to do it. And then the wallet converts these to EIL calls and performs them on their respective chains in the correct order.
Got it. And I mean, like in the past as well, like whenever a standard or even the smart contract wallet adoption, like it kind of relied on the existing wallets to modernize themselves, right? And that has halted adoption in certain ways. Like, do you think that will be a major challenge for the EIL?
So we've already been talking to a bunch of wallets. So Ambire Wallet has a version of EIL, has a version of their wallet that supports EIL.
Uh-huh.
So wallets are excited about adopting EIL. I mean, I think with anything, the question is in the adoption. But I mean, as we've seen with account abstraction 4337, which has over 800 million transactions, like over 50 million users, we've seen that we've been able to get to a large scale of adoption. So I'm sure that with EIL, we will as well.
Hmm. Uh, and what do you think about like the account abstraction players, right? Because they've been building a certain logic a certain way for the longest time. From that perspective, like how does the EIL fit into what to the work that they've been doing?
Yeah, I think it fits in really nicely because EIL builds on top of account abstraction. And as account abstraction improves, like for example, when we get native account abstraction with EIP 7701, which hopefully, fingers crossed, will go into Hagoda. So yeah, as account abstraction improves, EIL will as well. And EIL is really just an extension of account abstraction, and it's just a whole nother use case or paradigm for account abstraction. So we really think that the account abstraction players and the ones that we've spoken to in the ecosystem have been super supportive.
Got it. And like in your launch blog itself, you specifically mentioned that like there are no solvers being involved because like there are centralization issues, there's censorship issues. So maybe can you talk a little bit about like what assumptions about trust or coordination did you explicitly try to avoid with the EIL?
Yeah. So how EIO works is we have XLPs, so cross-chain liquidity providers. And we differentiate those from relayers and solvers
Mhm.
because solvers and relayers, they get your transaction. They're executing it for you and they see your intent of what you want to do. So I like to compare this to an analogy of, let's say I'm going from New York to DC. I can either get there via a bus or I could drive a car, for example. So
Mhm.
an intent is kind of like a bus ticket. So I buy my bus ticket. The relayer like gets my funds and the call data, and sometimes they even get my IP address and my name, and they know who I am. So they could stop the bus, for example. They could reroute it, they could censor or, force me off the bus. And that's just like the trust model I would say that like solvers operate under. Whereas EIL is like I'm driving my car from New York to DC and I buy gas. So in that instance, the liquidity provider is just like the gas station. So they can either decide to give me the gas or they can decide not to. So they have no influence like over my route or like my timing or my destination because I'm the one that's like controlling that. So they can either just decide. So either I get the gas from them or the voucher, or they don't. So the bus basically has to know my intention or where I'm going in order to get me there, but the gas station doesn't. So that's kind of what we were thinking in terms of like when we wanted to design EIL to solve this mid-state problem of like once I give the solver my intent, like I'm now dependent on them. They have my money, etc. Versus with an XLP, like they they like never see the user's calls, they never execute anything. They just basically claim the user's funds by signing a voucher. Um, so economically, I would say XLPs and solvers are like quite identical. But the difference is just how much the user has to trust them. Um, and also, I would add that in EIL, all of the transactions are atomic, for example. So, like, either this all happens on all chains or nothing happens. And in that instance, there is no mid state because, for example, with a solver, let's say I don't know, let's say that on my source chain executes, but then on my destination chain fails. Then I now have not gotten my funds on the destination chain. And so I'm stuck in this mid state. And so with EIL and XLPs, you don't have that because everything is atomic.
Hmm. I mean, like you mentioned, so there's also another key point for XLPs, right? Like you don't have to give away too much information about your intent, whereas with the solver model, like you have to explicitly tell, like, this is my order and this is what I want to get out of it. Whereas I think with the XLP model, you just have to claim a voucher with the providers. You have anything to add on that, like the intents versus bridges debate, or intents versus EIL debate?
No, I think you started by asking the question about assumptions, about which I understood to be like, what are assumptions that we try to avoid, which exist in other protocols. So I would say at a high level, it's first of all no execution by third parties, meaning you always self-execute your calls. And that's important because there are many griefing and censorship vectors with a third-party execution. We can dive into that later, but anyway, it's a really hard problem letting someone else execute call data on your behalf. People often don't realize how difficult it is to get it right and to ensure security. So that's one assumption. Another one is like a no off-chain interaction with third parties. And that's important both for censorship and for privacy, because I don't necessarily want to reveal my IP, my identity, where I'm connected from, because then I might get censored, or I might get reported to places where I don't want to be reported. So no off-chain interaction. Everything must be on-chain. And as Marissa already mentioned, no mid states in the sense that it's atomic. I want user funds to always be under the user's full control. So like either you have your funds or can claim them without help from anyone on the source chain or the destination chain. They never sit somewhere else where you need to wait for someone to do something. So these are the main assumptions we try to avoid.
Like, how real is the IP address leak issue with today's protocols, right? Like, because I'm assuming every protocol would be collecting this data, right?
Yeah,
Unless they
I would say
can't. Yeah. Okay, go on.
yes, unless they can. But yeah, I would say it is a real problem, and importantly, it's very invisible to users. So like today, like most bridge and intent flows basically require the wallet, or like the front end to talk to some like off-chain infrastructure, like solver APIs, like endpoints, etc. And then the moment that you've done that, you've basically leaked a bunch of metadata. So you've leaked your IP address, like the timing, your wallet address, your intent, etc. So then now that server can link my address to my identity. Let's say, like, I don't know, I'm from an OFAC sanctioned country. Then that server could then block me from having access to my own funds, which would then violate self-custody. So basically in any instance where like a server requires, or where I'm required to ask a server for permission, then that server is going to learn something about me. And so EIL in its design tries to remove this like entire, I guess, class. Because if your wallet can construct and submit the transaction directly, then you don't need to trust an off-chain server.
Mm-hmm. And I think like I haven't heard of too many cases where this has happened, but like recently there was a tweet from Grant, who's the founder of Blockmates, and he had a debridge transaction blocked due to like a solver level compliance check. And I think like this is the issue that you're trying to avoid, right? Like if there are certain servers that are collecting IP addresses, and for some reason they decide that this address should not be uh, allowed to use a protocol, they can just like sanction you, or they can, in the worst case, they can actually like freeze your funds.
When we build systems like Ethereum, when you build a blockchain, you have to think about, not about how often does it happen, but like you have to prevent it from ever happening, because otherwise there is no reason to use it. Like, for example, we have a Venmo or PayPal, and they work great actually. It's the user experience with Venmo and PayPal is really nice until they decide to freeze your funds for whatever reason. And then, and if you read some threads in eBay seller forums, it will become apparent that like how powerless you become when they freeze your funds for goods that you already sent to someone. And this happens to people. So this is a real problem. And that's why we need self-custody. So for systems, the systems we are building with Ethereum and with EIL are meant to solve that. Because building a system that is optimized for the happy case, where usually it goes fine, usually no one will try to censor the user, that's it's much easier to build them. They can be cheap and efficient. But Ethereum picks the hard way of building systems that offer guarantees also in the unhappy cases. EIL just extends the same to interop.
And in the unhappy case that it does happen, I think like you're using the main Ethereum canonical bridge uh, to verify those transactions, right? Like wherever the griefing of like a user does happen with the XLP. So I think like early on there used to be many bridges that use this design, but I think a couple of years ago, like this process used to be super expensive and super slow. So those bridges did not like take off, and that's why we had third-party bridging solutions come to the market, right? So do you think in today's ecosystem, like this issue has been resolved of like slow canonical L1 to L2 bridging?
So actually, the canonical bridge is not involved unless is not involved except for the case of a fraud proof. So it's not, I mean, if someone tries to censor you, since in EIL they can't censor you because you self-transact, and they can atomically either sell you a voucher or not, and then someone else will sell you a voucher because it's permissionless. So actually, the canonical bridges and L1 are not involved in the process. The only case where they become involved is if someone actually tried to rug pull you, like to
Mhm.
someone gave you a voucher, and then immediately as they give you the voucher, they also withdraw all of their liquidity from the destination, so they become insolvent. Now, in this case, you do use a fraud proof, and I expect that this will like never happen. This will never happen in the real world. So the cost of this fraud proof, it's okay if it's high because it never happens. And this is exactly the same situation as with optimistic rollups. For example, when you use Arbitrum, if you needed to activate the fraud proof system, it's an interactive process on L1 that will be super expensive, but it never happened in real life. You know, Arbitrum has been live on Mainnet for several years, and this never happened because it would just be so expensive. Since if a sequencer tries to do that, it has no chance of getting away with it. It will get slashed, and the bad things will get undone. So there's no incentive to do it, and they're going to get slashed. And therefore, it never has to happen. So nobody ever has to pay these expensive fees for proving. And we use exactly the same model. We have fraud proofs so that you never have to use them.
Okay, got it. So like you're betting on the fact that because it doesn't make economic sense, like it will most likely never happen. And in case it does, like then the cost of a fraud proof will be worth it.
Oh yeah, it will be because the way we just have to incentivize making the calls, making two calls to prove it. So the cost of these calls has to be lower than the reward you're getting. So if you have if the XLP has to put a one ETH bond on L1, they have, like I said, they stake one ETH, and then they become an XLP and they start providing liquidity. And then if they don't provide liquidity, like if they give you a false voucher that does not have liquidity on the other end, then you're going to get by proving it, you're going to get rewarded from this one ETH, which is a lot more than the cost of submitting the L1 transactions. So it becomes a no-brainer. Someone will make these calls. It's like it's free money.
Makes sense. I mean, free markets will do their thing, right? Like somebody would come in and always take that like money on the table, which is lying, and then just like the issue will be resolved in that case.
Yes, that's the crypto economics ensure that.
Awesome. And like from the perspective of bridges, like if all of this logic is built into the wallets themselves, what does the EIL mean for bridges? Like if everything happens in the wallet, will users need to go to like use a DEX or use a bridge front end?
Yeah, I think it just depends on what type of bridge. So, like for example, like EIL depends on the canonical bridges, so those will definitely stay. And I would say token issuance bridges that represent assets on different chains. XLPs rely on those representations, and those token issuance bridges will still be important. I think the bridges that EIL hopes to replace is those custodial bridges where the user has to trust an operator to either do something on their behalf or temporarily hold their assets.
But like,
Go
go
ahead.
on.
I was just saying that that's I mean, when we talk about bridges, we think about this on-chain representation, which are the types that Marissa mentioned. But I think you mentioned front ends. So I
Yeah.
understand it. Maybe when you say bridges, you're not talking about these canonical bridges versus operator bridges, but actually a website that the user goes to perform a certain operation. So in that sense, actually, whether it disappears or not is up to the wallets, because the wallets can implement it. The wallets can implement it internally using EIL, or you can go to you can go to a website that sends a certain batch that includes such bridge transfers, and then the wallet performs them. So whether you need the front end for this or not is up to the wallet. But this front end is actually it's not the case we are focused on, because I mean asset transfers. When asset transfers is something that you can do with EIL, but EIL really shines when there is actual call data, when you actually try to do something with the funds rather than just transferring them.
So I think what you're saying is like you can still go and use a front end, but that's more like collecting the intent, and everything will happen in the wallet itself. So like in a way, the wallet could basically cover for that intent in the wallet itself with the EIL, but like it depends on the user. Like where does he go to fulfill their intents?
Yeah, the instructions, even though in this case they are not intents, they actually, I mean, it's actual call data. But when the user goes and uses some DApp, which is just a website you go to, and this website tells the wallet what to do. But once it tells the wallet what to do, now it's up to the wallet to determine it. And with intents, what the DApp would do is the DApp would actually send the intents to an intent protocol and have solvers figure out what to do. And here instead, the DApp says exactly what it wants to do, and it tells it to the wallet. And now the wallet makes it happen. So the user has direct control. The user actually signs the operation, and then the wallet orchestrates it.
Got it. And like, where does the EIL fit alongside everything else that is going on at the Ethereum Foundation with like so many other efforts going on for Interop, right? Like the work Josh and Barnaby are doing with the open intents framework and fast finality.
Yeah. That has been a very frequently asked question. So yeah, I would love to clarify that. So I think just want to start by differentiating between what is an intent and what is a transaction. So intents are this high level abstraction that specify the end result. You could look at across this definition or paradigms definitions of this, that intents specify the what and not the how. So intents are declarative, whereas like transactions are more imperative. Transactions are these low level instructions, which is basically call data to execute. So OIF, which is the work that Josh and Barnaby have been working on, focuses on intents, and EIL focuses on transactions. And there's use cases for both, but I would just say they each address a different layer of the problem. So EIL focuses on how cross-chain actions are executed. So it extends basically Ethereum's single chain execution model of transactions to multi-chain via account abstraction, all while being trust minimized. So I would say that EIL answers this question of how can we safely execute known calls across multiple Ethereum rollups? And I would say that OIF answers a different question, which is how can I optimize this execution when the user doesn't know a specific piece of information or the exact call? So like intents are super useful when there's information asymmetry. CowSwap is a great example of this. So like, let's say I want to swap token A to B and I want to get the best price. I need some information that I, as the user, don't have. So I would say like that is largely the difference between OIF and EIL.
And I would add that even though the two projects address different needs and use like different abstraction levels, But there is one place where they could intersect in the future, is that since EIL can be a lower layer that provides trustless execution, you could use it to make OIF trustless, at least for some use cases, by implementing what we call a local solver. Suppose you take, the solver, you can look at a solver as a black box. It gets an intent on one end, it gets an intent on one end, and then it spits out a bunch of transactions which it executes on multiple chains. So if you have this black box that currently runs on a server, you don't know the logic, it has some opaque logic, which then executes transaction. With EIL, what you could do is you could run this. You could make this black box transparent, run it on the user's machine, and then perform exactly the same logic and use EIL to execute the transactions. So there are some challenges to solve, like how do you get price quotes and all that. So it would need some additional projects to make it work. But technically, you could use EIL to make OIF trustless by solving locally.
Got it. So there are certain like tracks where you can use a combination of like the OIF and the EIL.
Yes, definitely. We see them as complementary and not competitive.
Makes sense. And I think like another a question that was often asked was basically like, if the ecosystem itself is much more than just Ethereum, like, does it make sense to have an interop layer just for Ethereum? Like, what about Solana and what about like all the other chains, like non-EVM chains?
Yeah, we built EIL kind of starting with the least trust assumptions possible. And given our background in account abstraction, that's kind of how we thought through it from an account abstraction perspective. And we think of it as building blocks. So like, okay, once you make the Ethereum layer itself trustless, then you can extend trust minimize interop to other chains over time. And which is what we're doing as we get closer to being live on Mainnet. EIL can also be integrated with other like trust minimize atomic swap protocols. So Train, I think it's train.app is the website, is an example of another atomic swap protocol. So that could add support for alt L1s. The latency would become higher. I think it's around like 4 blocks due to the HTLC process, but trustlessness would still be preserved. And we would definitely like love to see more integrations that would extend EIL to Solana and other chains in the future.
Nice. So there is a world where we can see like the EIL extend to Solana.
Absolutely.
Mm-hmm. Yeah,
not via
with
EIL itself, but like
that's not which depends on which part. Wait, EIL has 2 aspects. With EIL, we separated the you have the execution, which is we have the execution that must be controlled by the user, and you have the question of how do you pay for the gas or the equivalent on other chains, and how do you make your assets available. So we separate these 2 problems where, since the user is in control, the user actually performs the execution. This is always trustless, and this is trustless regardless of Ethereum. Like if you wanted to transact between, let's say, Binance Smart Chain and Ethereum, where you don't have this shared source of truth, it will still be trustless in the sense of call execution, because call execution is is actually is actually controlled by the user. And then the question, the part that is harder to make trustless is passing the value, like passing gas, or how do you pay gas, how do you pay or how do you make assets available. And for this, we use the voucher mechanism. Vouchers are an atomic swap that uses the fact that we have a shared source of truth to have this optimistic system with fraud proofs. And for this, you need the L1. So this is unique to Ethereum. But if you replace this part with HTLC, for example, by integrating it with the Train protocol, then it remains equally trustless, and you only use this for paying for the execution and for bringing the assets, and then execution works exactly the same way. So a version of EIL that supports alt L1s is basically the same EIL, the same execution model, but instead of the optimistic vouchers, it will use vouchers based on HTLC. As Marissa mentioned, the latency will be higher, but it remains just as trustless.
Got it. And I think like another critique in public was basically the fact that like calling it Ethereum Interop Layer might be false marketing because like the layer itself reduces user risks, but like it doesn't really solve cross-chain messaging, right? Like what do you guys have to say about that?
I would say that first of all, trustless messaging is not possible without 7 days latency in one direction or 14 days round trip, which is not practical for anything except for optimistic systems. And the reason is optimistic rollups. So if you want to send a message from one optimistic rollup to another, and you want to do it trustlessly, not by using some oracle that will attest for the state of the other rollup, you need to wait for the rollup's finality, which is 7 days. So, I mean, for optimistic rollup, or maybe several hours for ZK rollups. Now, it's trustless messaging is not something that you can solve for now. And currently, but it turns out that currently very few use cases actually require cross-chain messaging. User transactions don't require it. They can just the user can send a transaction directly on each chain, and there is no information from chain A to chain B, no information flow. The information flows from the wallet to both of the chains. And the only case where we do need information to flow between chains is the token transfer. And for this one, we don't need cross-chain messaging because we can do things like atomic swaps. So ultimately, like messaging is only required when chain A contract needs to directly call a chain B contract. And while this is the end game for interop, there are currently few use cases that require it, and EIL chose to offer the best interop layer possible without introducing Oracle, which means that messaging is out of the question for now.
Right. So like you're calling it the interop layer from like a utility and use case perspective, while I think like the critique comes from a very literal perspective.
Yeah, I mean
Yeah.
messaging. Yeah, it's, messaging is just a different. Messaging is a different layer, and it's a layer that we cannot have for now. But since or almost none of the interop use cases at the moment actually needs to have this trustless messaging, which we also can't do without oracles, we chose to make the interop layer for today's interop and for the interop that we expect to see in coming years, which is mostly user transactions.
Yeah, and I think some of the critique around the name comes from the fact that interop is such a broad category, and there's a bunch of different definitions for interop. You could have message passing interop, intent-based interop, or like EIL account-based interop. So by Ethereum Interop Layer, we meant account-based interop.
It makes sense. I think that's one of the biggest challenges, right? Like nobody can actually define interop particularly, and because it touches so many different aspects like chains, wallets, and like users from a utility multi-chain perspective, it's very hard to pin down on like an exact definition.
Yeah, super broad.
And so, what's the current state of the project, and like when can we expect it to go live, and how are you guys planning for the launch?
Yes. So currently, EIL is on testnet. We are working towards a more mainnet launch as we have now opened up the protocol for review by the community. It was really important for us to take into consideration feedback. We want to make sure we get rid of all the bugs, and go through a very extensive audit. At least one. And so currently we are finalizing changes to the protocol, taking in feedback, and we'll begin an audit. And then we hope to go live on mainnet in about 3 to 4 months from now.
Any like word for like the builders out there? How can they contribute to the EIL, and how should they look forward to it?
Yes, we would love people to contribute. I mean, every day I get someone messaging me with like some new idea they have for how they can use EIL in their own application. So it's really cool to hear all of the different use cases for cross-chain like execution composability. So we have a Telegram group, Ethereum Interop Layer. Perhaps we can put the link in the show notes. And you could write your questions there. We are willing to answer any questions that you have. I'm happy to chat with builders or anyone that wants to.
You have any last thoughts?
Yeah, that's a good question. So it's I think by making multi-chain calls seamless, low latency, and trustless, we enable use cases that we unlock use cases that currently are not possible because or currently are not feasible because until now either you use it on a single chain but then you are bound by the block capacity of L1, or you need to interact across chains in a way that is not as seamless. So by making it seamless, trustless, and feel like a single chain, we can unlock use cases, we can unlock things that did not exist until now, and we're excited to see what people are going to come up with.
Awesome. Thank you so much for your time today. And I think like everyone in the ecosystem is excited to see what the EIL will bring. And hopefully like a year from now, we can have a conversation and see what the EIL actually changes in the ecosystem.
Yes. Yeah. Looking forward to it.
Thank you. Thank you so much for your
Thank
time.
you.
Thanks.